Today you will be taking notes in your journal over speed, velocity, and acceleration. So if you will add notes, speed, velocity, and acceleration to your table of contents and note the page that you are going to begin the notes on, we will begin. The first thing you remember is we talked a little bit about motion on Monday in class. And motion is a change in position of an object compared to a reference point. So we're going to look at 3 different ways that we can measure or refer to motion. So the first way is through speed. So if you'll add speed to your definition, speed, underline the term, and then write the definition for speed. Speed is the distance traveled by an object in a given amount of time. I'd also like you to put the formula here that speed is equal to distance divided by time. Now remember, you can pause the presentation at any time in order to complete your notes thoroughly. In 6th grade, you learned about speed, and you learned to calculate speed by looking at total distance divided by total time. So we're going to do a little practice here for you to remember. Remember, distance here is your numerator and time is your denominator. So let's pretend that we've got an animal that's able to run 60 kilometers, which is my distance, 60 kilometers in 2 hours. So I take my distance and my time. If I wanted to figure out and calculate the speed in kilometers per hour, my numerator, the number on top, always goes inside the box, and my denominator always goes outside. So 2 goes into 6 3 times. Whenever I find a remainder of 0, bring down this 0. 2 goes into 0 0 times. So my answer is 30 kilometers per hour. Oops, I forgot my km here and my hour. Okay, so speed is one way we can talk about the motion of an object. We need to be able to differentiate between these terms. The next term is velocity. Velocity is the measurement of speed and direction of an object. So in velocity, the only difference is we added directions. Directions could be things like north, south, east, or west. So make sure that you've put your definition for velocity, and whenever we calculate velocity, we use the same formula because speed is distance divided by time. The only thing we're going to do is add a direction when we talk about an object. The last way that we are going to talk about motion is acceleration. Acceleration is the change of an object's speed or direction. Now remember, speed and direction is velocity. So you could also say that acceleration is a change in an object's velocity. So you can have acceleration where you increase your speed, decrease your speed, change its direction, make it stop, make it start, and that would all be considered acceleration. Now, one thing we're going to have to do is calculate acceleration. And there's a formula that we'll be using when we talk about Newton's laws of motion, as well as here is that when you have a force, it will take a mass and accelerate it. And you can calculate that relationship by multiplying your mass times acceleration. So if you'll please add this to your notes. We often shorten this equation with F equals ma. And this is our handy dandy, I call it magic triangle. We can use this to help solve equations. If you're not really comfortable with plugging in numbers for variables and solving for something other than force, this can help you figure out what we do with the numbers if algebra, you're not really comfortable with it. So I'm going to show you how to do that with some sample problems. I would like you to write down these sample problems, and we're going to work through them together for our practice. The first problem says, what net force So we're trying to find out net force is required to accelerate a car at a rate of 2 meters per second squared if a car has a mass of 3,000 kilograms. Now, I've underlined some important information. To use the magic triangle, I'm looking for net force. So with that case, imagine putting your finger over the F here, and that leaves M and A side by side. So that means you're going to multiply the mass times the acceleration to find your answer. So my mass is 3,000 kilograms, and my acceleration in the formula is 2 meters per second squared. So since they're side by side in the magic triangle, I simply multiply those. And as I work out my math, I'm going to get 6,000, and the unit for force is in newtons. So I'm going to have newtons here. Our next practice problem, it is asking what is the mass. So now I'm trying to find out mass. And with that, the problem wants to know the mass of a falling rock if it produces a force of 147 newtons. Well, I don't know my acceleration, but since it's falling on Earth, we know gravity accelerates at 9.8 meters per second squared. So I know my acceleration. So since I'm solving for mass, place your finger over the M in the formula here. When I cover that up, that leaves force divided by acceleration. So this is how the triangle can help you. When I cover up the M with my finger, that leaves force divided by acceleration. So whatever is my numerator, which is on top, always goes inside my division house, we can call it. So the force is 147. Acceleration is 9.8, because that's just a fact we know about our gravity and how it accelerates objects. Now I have a decimal here, so we have to do our division rules. We move our decimal over. Since there was a decimal here, I've got to move it over one place, so I'm going to add a 0 as I get ready to work my problem. So 98 will not go into 1 or 14, but it will go into 147. It'll go one time. So I have to subtract, figure out what I have left here. So I have to regroup and borrow. So 8 from 17. We'll go have a remainder of 9. 9 from 13 is a remainder of 4. And bring down my 0. Gives me 490. 98 will go into 490. I think 5 times. 5 times 8 is 40. And 5 times 9 is 45, plus 4 is 49. So we get a remainder of 0. So my mass is 15. Well, what unit do we have mass in? Mass as units are in kilograms. So I just put my unit of kilograms here. Okay. Our last practice problem, as you can guess, it says, what is the acceleration? So now I'm going to solve for acceleration of a softball that has a mass of 0.5 kilograms and hits the catcher's glove with a force of 25 newtons. So I have mass, I have force, and I'm looking for acceleration. So what letter are we going to cover up? We are going to cover up with our finger acceleration since we're solving for acceleration. That leaves force divided by mass. Whatever's on top, my numerator, goes inside my division box. So my force in this problem is 25. I divide it by the mass, which is 0.5. And again, I've got some decimals to divide by, so I have to move my decimal place over 1. That means if this is 25, I've got to take and move this decimal over 1, fill with a 0, bring my decimal up. 5 goes into 25 5 times. 5 times 5 is 25. Remainder of 0. I have to bring the 0 down. 5 goes into 0, 0 times. Since I'm looking for acceleration, the unit for acceleration is meters per second squared. So my answer is 50 meters per second squared. Make sure that you have copied all these problems and worked these problems in your notes. And we are going to spend the next 3 days in class looking at how speed, velocity, and acceleration are all different.